Today I will review equivalent fractions so I can strengthen my skills, and Connor will help me, and we'll both know that we have it when we can recognize and identify equivalent fractions. So here is our first set of equivalent fractions, and I'm going to demonstrate a couple different ways that we can prove equivalent fractions. You know, we can do true false, we can turn them into decimals, or we can simplify the fractions. So the first thing we do need to do, no matter what we do, is identify what fractions are represented here. So I see 3/5 because I've got 1, 2, 3, 4, 5, and 3 of them are shaded in, so total of 5 pieces, 3 shaded in. So that's my goal fraction for each one. This one is 2/5. This one appears to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, and there appears to be 1, 2, 3, 4, 5, 6. 6/10. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one's also 10. And I've got 3 of them shaded in. And finally, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 of them shaded in, or 8 of them total, 6 of them shaded in. So for my first one, I'm going to simply do a true-false, and I'm going to set it up like so. Well, I already know that 3 is bigger than 5, and they have equivalent fractions, so I don't need to do anything about that. So it is definitely not that one. Now for 6/10 and 3/5, I'm going to set this up as a true or false, but they have unlike denominators, so I'm going to use my work area right down here. So 6/10, well, I know the LCM of 5 and 10 is going to be 10, so 6/10 is fine. And I just need to change my 3/5 into tenths. So something 5 times 2 equals 10. Whatever I do to the bottom, got to do the top, so it's one whole. So it gives me 6/10, which means these are equivalent, so this is a possible answer. So what I'm going to do for my next one is I'm going to turn it into a decimal. 3/10 gets expressed as so, and I already know that 3/5 is 6/10 as a decimal. That's like so, so I know those are not equivalent. And finally, I'm going to take 6/8 and I'm going to simplify that fraction. And 6/8, so I've got 6, I've got 8, do my t-chart, 1 and 6, 2 and 3, I'm done, 1 and 8, 2 and 4, GCF being 2, they have a common factor of 1, divide this, and so divide by 2 over 2, it's going to give me 3/4, and then I can turn 3/4 into a decimal, and I know 3/4 is like 3/4, so that's 0.75. 0.6 is not the same, so that's not the correct answer. So I was able to use some skills from fractions, some skills from decimals to prove my answer. It doesn't matter to me if you wanted to do all true falses, all simplifications, all decimals, doesn't matter to me as we go into our next example. So for our next example here, we've got one whole here, which we know that's not included, and then we've got a model. So figure out which point is equivalent. Alright, so hopefully by this point you have identified what it is. So I see I have one hole here, so that would be one hole. And I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. 1, 2, 3, 4. 4 of them shaded in. So I know that W and X cannot be correct because they are less than one hole. So I've already done myself a favor and I've eliminated like half of my answers. So now I need to identify what each one is. So I've got 1 piece, 2 pieces, 3 pieces, 4 pieces. So these are going to be a common denominator of 4. So I've got 1 and 2/4 for Y, and I've got 1 and 3/4 for Z. Now at this point I have all 1, so I can kind of just disregard my one hole because I don't need to really do anything with it because we're established that they all have the same whole number. So now we're just looking at the fractions. So I know that I can simplify 4/8. And that will give me 1 and 4, 2 and 2, 1 and 8, 2 and 4. If I simplify, that'll give me 1. Oh, let me change my pen. That'll give me 1/2. And I know off the top of my head that 2/4 is an equivalent fraction for 1/2, so that's 1/2. So I know that y works, and I know 1/2 is 0.5. It's because it's like half a dollar, and 3/4 is 75 cents. So I know that that can't work. Well, that's going to bring us to our bring back to school problem here. You got some stars shaded this time, and now I'm worried about the quadrilaterals. Which ones are equivalent? So I do not mind how you want to do it. Just make sure you demonstrate your work in some way, shape, or form. So once again, you can do a true-false equivalent, you can do a simplification, or you can change them into decimals, or you can do a combination of them all. So this is what I'll be looking for. I'm looking for both your work, and clearly please identify what your final answer is.